Assalamu alaikum. How are you, my dear students? Hope you will be in the best of health, wealth, and happiness. I welcome you all into my today lecture. Today is our lecture number 6. It is all about the thermal properties of matter, which is quite new beginning of, and that is the unit number 7. In this chapter, we will study about the effect of temperature on the physical properties of the matter, that how the properties of the matter changes when the temperature changes. Beside this, we will also learn about the thermometer, about the how thermometer is used to measure temperature, and we will learn about the heat also. So let us start with the name of Allah Almighty and Bismillah Rahman Rahim. So let us start with our first topic, and that is the temperature. Temperature. Now, what is the temperature? Temperature, it is the degree of hotness or coldness of the body, or we can say here, this is more appropriate, and I'll be telling to you why. That it is the measure of, this is more meaningful, it is the measure of, it is the measure of the average, it is the measure of the average kinetic energy of the body, of the molecules of the body. So that is called temperature. To get the idea of the temperature, let us start with some example. In our daily life, we come across many things which we feel hot or cold. For example, if you touch the ice, you get the feeling of cold, right? And you feel that ice is cold, right? And when you place your palm or hands or finger on the flame, then you get the feeling of as hot. So we say that the candle flame is higher temperature. And why? Because, and we say that it is hotter. And for the ice, we say that it is at lower temperature, and we call it the cold, right? Now, the degree of hotness and coldness, as I told you, that sometimes it does not convey a very good message. For example, if you take the warm water, right? Like if you, for example, look, let us see a kind of, I will just take you the example. For example, like this. If you take just normal water, right? And if you just take cold water, right? The normal water and the cold water, and then you just see water at nearly freezing point, right? That is kind of freezing temperature, at the freezing temperature water, for example. So if somebody asks you, then definitely when you compare these two, then you say that the water here, this is also water, and this is also water, and this water is at nearly freezing temperature, right? Like this. Okay, then when you compare these, for example, this A, B, and C, and if you compare the A and the B first, and if somebody asks you which one is cold and which one is just normal, definitely you say that this water is at considerably normal temperature. You say that it is it is hot, and about this you say it is cold. But when you compare these two, right, then when somebody asks you, then what you will say, to this cold you will call that is warm water, and to this freezing temperature water you will say that it is very cold or it is cold. So to this, you say, you said before to this is cold, now you say it warm when you compare it with the water at a freezing point. So this is why this idea of cold and hot does not give sometime very good impression. So this is why it is best that we measure temperature, or we just speak about temperature in terms of the measure of the average kinetic energy of the molecules of the body. So here the energy is very low, and here the energy is very high, and here the energy is low. So this is why it will be cold, and this will be what, this will be hot. Now there are the measuring the temperature, that how we can measure the temperature. Yeah, why first, why we measure the temperature? Because of many reasons, right? For example, there is the sometime that our sense, as I just told you, that our sense of touch is a simple way to know whether a body is hot or cold. But the temperature sense is sometimes unreliable, and we need a very accurate method of determining the temperature of a substance, right? Is another thing that we cannot always touch hotter bodies, that might be a danger. So definitely we need some ways to measure the temperature accurately and safely. So I'm coming to that point. First, how how our sense deceit this, how we cannot rely much on our sense of measuring temperature. The same example I will choose. For example, if we have three bowls, like one this, three vessels, and one this, clear. Let's say that this contain that here it is water at room temperature, normal, I will like. Here we have fairly hot to the extent so that you can place your finger inside it, not very hot. And here we have the cold water. Now just place your left hand, right, there is, yeah, in the hot, and the right hand in the cold water. And now you, what you will feel, the hand which is in the hotter water now feel hot, and this you will get the feeling of hot. Here you will get the feeling of what, cold. Now take out both of your hands simultaneously and place your left hand and your right hand in the normal water together, and you will have a very strange feeling. Your left hand, which was feeling hot before, will now feel cool effect. It will feel cold. And the hand, the right hand, which was feeling cold before, will now feel hot. So water is the same here, and you get different feeling. It means that our sense of temperature is not reliable for for determining that whether something is hot or cold, for and why this thing happened. It is because that heat always flow from hotter bodies to cold body, right? So now when you place your left hand, which was hard before, Now, since this has a temperature, it has a temperature greater, for example, T1, T2, and this is T. So here what is happening? T1 is greater than T2, and here what? T2 is less than T. Sorry, T. So the hand which was feeling hard before, now heat will transfer from your left hand to this normal water, and your left hand will feel cold. And similarly, the hand which was feeling cold now will gain heat energy from the normal water because it was cold. So it will feel hot now. So this is why our sense of temperature is not very much reliable. Clear? So in order to understand the concept of this temperature and the temperature measuring instrument, we need to understand some more concepts, right? Which will help us. The first one is the thermal equilibrium, or first the thermal contact. The thermal contact. Now, what is a thermal contact? Thermal contact is the contact between two bodies which easily allow the flow of heat. Then we say that the bodies are said to be in what? In thermal contact. For example, look, if you make a connection between the normal water and the hot water through some metal wire or through some other substances, right? Then we say that there is what? There is a thermal contact. Yeah, for example, look at the water in the hot cup like this, for example, here. Let's say, for example, if it is now, do it in another way. Let's see, for example, we have tea here in a cup, as you see. Now, after some time, when you see that it becomes fairly warm, and then it becomes warm, and then after even more time, it becomes cold. Now, why is this thing happening? We say that the cup, the tea in the cup is in thermal contact with its surrounding, right? And the heat can easily flow through that thermal contact from hotter cup to the surrounding like air. So whenever two bodies are in thermal contact, then thermal contact always allow the flow of heat. Always allow the flow of what? The flow of heat from one body into another body. And we say that the body are in what? And the bodies are in thermal contact. And then there is thermal equilibrium. This is very important for the designing of the thermometer. Thermal equilibrium. Now, what is thermal equilibrium? Whenever two bodies are brought into thermal contact, that is when and heat will flow from hot bodies to the cold bodies until both the bodies attain the same temperature. And we say that the bodies are in thermal contact. The bodies are in the bodies are in thermal equilibrium. For example, if you have one body A and it has temperature T1, if you have another body B and it is at temperature T2, such that T1 is greater than T2, and when you brought them together in a thermal contact such that heat can flow from the body A to the body B, this was the body B and this is the body A, then what will happen? There will be heat flow from the body A to the body B. Since the body A is at higher temperature than the body B, then after some time, both the temperature of the body A and the temperature of the body B will be the same. Let's say T. Okay, so we then call both the bodies A's in thermal equilibrium. The bodies are said to be in what? The bodies are said to be in thermal equilibrium. So this is how the energy, this is why it is because of the fact that heat energy is transferred from a body which is at higher temperature to the bodies which are at lower temperature. And then there is another term associated with it, and that term is called the thermal. That is called what? That is called the internal energy. Internal energy of the system. Internal energy. Now, before telling you something about the internal energy, I would like to tell you something about the heat also first. What is heat? We sometimes we say that heat, the simplest way, that heat is the form of energy. Heat is what? Heat is the form of energy which is always in transit. In transit means in motion, right? In what? In motion. So heat is the form of energy which always flow from, that is heat, the form of energy which always flow from hotter bodies, from hotter bodies to colder bodies, to colder bodies, which always flow from what? From hotter bodies to the colder bodies, right? Heat what? Heat always flow from hot bodies to the cold bodies. This is why we say that heat is always in transit. But I would like to tell you that in my opinion, heat is nothing but it is just the method of transfer, just the method of transfer of energy. Why? Once the heat enters into the body, it is no more called heat. Rather, it is called the average kinetic energy of the molecule of a substance. And together we call this energy as the internal energy of the system. So what is the internal energy? The internal energy, the internal energy, the internal energy of the system is the sum of, it is the sum of the kinetic energy and potential energy associated associated with the particles, associated with the particles. By particle I mean atoms or molecules. The particles of what? Of the body, yeah, that object or that substance. Now the question is that where the kinetic energy comes from and where the potential energy comes from. The kinetic energy associated with the molecule of the bodies, that comes from the fact that molecules are always in motion, atoms are always in motion for the matter. This is what, when I was explaining to you the kinetic molecular theory, I already told it to you there. So that is the about what? That is about the kinetic energy, that how the molecules are, the particle of that substance have. The potential energy. Potential energy, this is little bit difficult, not that much, but can you tell me from where the potential energy comes from for the molecule? It is because of the binding forces there. Due to what? Due to the binding forces between the molecule of a substance, right? That the molecules are bound together, right, with a force, right? And because of that force, the molecules have the potential energy. And this energy, the sum of this kinetic and potential energy together is called the, it is called the, internal energy of the molecule of the substance. So the internal energy depends on many factors, It depends on the mass factors for the internal energy. And this depends on the mass of the substance. Greater the mass, greater will be the internal energy. The second, it depends on the temperature, that increasing the temperature, increasing the internal energy of the uh, molecules of the system, right? So these are the factors which increase which can affect the internal energy. So that is the temperature. I means that the heat energy, that if you increase the temperature of a substance by giving them heat, so you are actually increasing the internal energy, right? So heat is transfer, heat actually transfer the, for example, look, if you have here this water in a beaker like this, and if you heat the water in a beaker, so what happens, that heat transfer energy from the flame of the candle to what, to the water, right? And in turn the water temperature rises and its internal kinetic energy increases. So mass, temperature, they affect the internal kinetic energy of the substance. Now our next point is the thermometer. Okay, let me do it here. So what were the factors for this? Let me later on, if I PDF this lecture for you, so you should see the temperature, mass, as well as temperature, right? These are the two factors which affect the internal energy of the substance. The next topic is the thermometer. Now, what is thermometer? Thermometer is a device which is used to which is used to which is used to measure the temperature of a substance, or a place of a substance or a place, is called what? Is called thermometer. Now, what is the working principle of the thermometer? The working principle. The working principle of the thermometer is based on the phenomena that liquids, yeah, substances, yeah, objects expands on heating and contract on cooling. This will be the basic principle we will use in the design of thermometer. There are other principles also. For example, resistance thermometer, they may have a different working principle. Infrared thermometer may have a different working principle. But here for the liquid and glass thermometer, we will use substances expands on heating and contract on cooling. So since we will be interested in the liquid and glass thermometer, so therefore I will write liquid, right? The liquid in what the liquid expands on heating and contract on cooling. So not all of the liquid can be used for measuring the temperature of a substance, right? It can all of the liquid cannot be used as a thermometric substances. So there might be certain properties to use that liquid for measuring the temperature. We call that thermometric liquid. Which liquid? Thermometric liquid. And the thermometric liquid may have some properties, right? And I just want to explain to you the properties. First of all, the first thing is that it should be visible. It should be what? It should be visible so that we can see when we take reading. So in a liquid which is not visible will create problem for us. We wouldn't be able to find the exact reading. So the liquid must be visible first. The first point is that the liquid must be what? That the liquid must be visible. The second important point is uniform thermal expansion. Uniform thermal expansion. Thermal expansion is, I told you in the beginning that liquid expands on heating and contract on cooling. But this expansion and cooling, it must be uniform, right? For the same rise in temperature, there is the same rise, the same expansion, sorry. So uniform thermal expansion must be one of the most important point. The high boiling point, yeah, low freezing point, low, the liquid should have low freezing point and high boiling point, high boiling point, right? So that should be what, because if we want to measure the higher temperature, so the liquid in the thermometer should not boil at the earliest, or if we want to measure a temperature as low as to the level of the freezing point, then the mercury should not freeze first. So the liquid mercury is not necessary, any liquid which have this property. So low freezing point and high boiling point is another important point. It should not wet the glass. Should not wet the glass. It should not be wetty. Right? Why? Because if it stick to the glass, then for the next use or the reuse, it will be very difficult, right? Because we wouldn't be able to find the exact reading, or we should wait for longer then. So it should not wet the glass. It should not stick to the wall of the glass. It should not be that much adhesive, right? To other substances. And another important point is must be best conductor of heat. Best conductor of heat. It should be what? It should be best conductor of heat, right? It should conduct heat very quickly, and it should have what? Small specific heat capacity. Should have what? Small specific heat capacity. What does this mean? We will explain it later on, but specific heat is the amount of heat energy required to raise the temperature of unit mass of a substance by 1 Kelvin, right? So even I would like to tell you here right at this point that small specific heat means that a very quick response even to very minute changes in the temperature of a substance or region. So if any liquid which qualify these conditions can be used for what? Can be used for the liquid in glass thermometer, and mercury is one of the best, right? So let us now start how a liquid in glass thermometer can be constructed. So a liquid in glass thermometer is shown right here, that I show it at the 3 stages. The first one, and then the second one, and here is the third one. In the third, I all label it. If you just see, let me tell you first about the parts of this thermometer, then later on I will tell you how it is calibrated. A liquid and glass thermometer has a bulb with long capillary tube of uniform and fine bore, right? You just see, look, this is a liquid and glass thermometer. Here you see the bore of uniform size, like here, just look at this diagram. See here, like in this one. Let me just choose this. As you see here, like this. So here is what? There is a fine bore, as you see, and it is filled with what? With a liquid. As you see the liquid here, we use mercury, like here as you see it. Okay, this is all mercury. And then there is a bulb. The bulb has a protecting cover, right? And it's the bulb is has a metallic end which is best conductor of heat, so that heat can easily be transferred from the body or from the mouth to this mercury indirectly. Why? Because mercury is very poisonous, so there should be a strong protection between the mercury and the person who is using it. So there is a protective cover also, and it is then filled with the best conductor so that heat can easily be transferred, right? The bulb is usually the bulb. This comes in what? In contact. Whenever it comes in contact with a hotter object or with any object, then it quickly transfers heat from the object to the mercury, and the mercury responds, and in the mercury tube it rises and indicates a temperature which can be noted down by using the scale here. Now, how the scale is designed, I'm coming to that point. The most important point here is I told you that low freezing point and high boiling point. So for the mercury, the freezing point is minus 39 degrees centigrade, and the boiling point for it is I think 57 degrees centigrade, right? So this is one of the reason that it could be one of the most suitable thermometer material for our thermometer. Now, how to start, how to calibrate a thermometer. So as I told you that we have the fine capillary tube, and it is filled with what? That it is filled with the glass, it is filled with the tube, it is filled with the mercury, right? Then the mercury will descend, will attain the lowest level when it is kept in pure ice, pure ice. Okay, there will be a stage reached that where the level of the mercury in the tube will not drop down or will not drop anymore, and we mark that point as the lower reference point. So in order to calibrate the thermometer, we have the reference point, because we have to start from somewhere. Just like if you have the meter rod, so your lower reference point is 0 and the higher reference point is 100 degrees centigrade. So similarly for the thermometer, we have also the lower and the upper reference point. So what is the lower reference point? The lower reference point is then taken as the freezing point of water. The freezing point of pure water, right? So we will mark that point where the mercury does not go down any further, does not descend any further. That point will be marked as the lower reference point. Okay, and then we will start heating the ice cube, right? Like as you see. Now we are going to increase the temperature, right? The water will now, the ice cube will now start melt. Its temperature will rise, and you will see that the mercury in the tube or in the column will start rising. and let me show you is like this. As you see, look, it is rising, rising, rising until the all of the water starts boiling. And once the water start boiling, the mercury will stay at a particular point and that it will not rise anymore. Why? They now at this stage that when the water is boiling, there is no rise in the mercury level. I will explain this when I explain you the latent heat, right, topic. So at this point it is inappropriate. Okay, and I will label that point as the upper reference point. Upper reference point. Okay, so the upper reference point is taken as what? The boiling point of a pure water. Boiling point of the pure water. Now you have the upper reference point and you have the lower reference point. So the distance between the upper and the lower reference point is divided into division which suits best your scale. So for our case, we divide this, for example, into 100 division. We mark the lower reference point as 0 degree centigrade and we mark the upper reference point, we call it as 100 degree centigrade if it is a centigrade scale, and the length between the upper and the lower reference point on the scale is divided into 100 division such that each division, this single division is called degree. It is called what? It is called a degree. So this is how the thermometer is calibrated, and then it will turn into this shape, right? And which can be then used. Clear? So this is how the liquid and glass thermometer can be. Right? Now there are the scale of temperature. So let me explain to you the scale of temperature. There are various scales of temperature. There are three scales of temperature, and I will explain to you these three scale of temperature one by one right here. Okay, now look, the we have the Celsius scale or the centigrade scale. In the Celsius scale or the centigrade scale, the lower reference point is taken as 0 degree centigrade. This is our lower reference point. And the upper reference point is fixed on 100, as I already explained it to you. And this length is divided into 100 equal parts, right? Into 100 equal division, right? 100 div, such that one division here is called 1 div. It is called centigrade. Centigrade. Why? Because it is divided. Centi means one over a centi means 100. So it is divided into 100 division. This is called. This is why it is called the centigrade scale or Celsius scale. Or which scale? Or the Celsius scale. And then there is a Fahrenheit scale. The Fahrenheit scale, here you see that the lower fixed point is taken as 32 degree Fahrenheit and the upper reference point is called the 12 degree Fahrenheit. It is called what? It is called the it is called the Fahrenheit scale. The that is the length between the upper and the lower reference point is divided into 180 divisions, and each division is called a degree Fahrenheit. Okay, so if you just see here, you have 100 division and here you have 180 division. So the Fahrenheit scale is more precise than the centigrade scale in this regard because we have very small number of division here. And then we have what? And then we have another scale called the Kelvin scale. It is called which scale? It is called the Kelvin scale. The Kelvin scale, this is the SI That is, here Kelvin is the SI unit, so it is actually the SI scale, right, for measuring the temperature, where the on the SI scale the unit of temperature is what? It is Kelvin. And since we have just taken the lower fixed point and the upper reference point, the Kelvin scale is based on a natural law. What? On a natural law. And what is that natural law? That is the Charles law. Charles law. It is based on what? It is based on the Charles law, right? What does the Charles law tells you? That the Charles law tells you that the increase, that is increase in temperature increases volume, and decrease in temperature decreases volume. So when we plot the graph between volume and temperature, then when you decrease the temperature of a substance, decreases at a temperature, we call that temperature as the minus 273 degrees centigrade. We call this temperature as the 0 Kelvin, or the absolute temperature. I will explain the Charles law. Absolute, absolute temperature later on, because it is not appropriate here. But I just want to tell you that why this scale is important, because it is based on on a law, right? So this is more of a standard. So now you know that once this is the lowest achievable temperature. Until now, no, this is we sometimes called the ideal temperature, because we cannot achieve the temperature of minus 273 degrees centigrade. We can achieve minus 272.99 like that, but cannot minus 0.273. Why? Because you just see on the temperature scale here, the volume of the substance is zero, means the volume vanishes, means the object vanishes, which is against the law of conservation of mass. Right here, the molecular motion of the particle of the medium cease to exist, and which is against the KMT. So this temperature is not possible, right? Until now, this cannot be observed. So this is why we have the 0 Kelvin here. And then the rest, it is divided into what? Minus 273, then plus 373, then it will become what? 273, and then 373, and this is divided into what? 100 equal division. So this is what? This is a Kelvin scale. Now how we can convert from Kelvin scale to centigrade, or from centigrade to, from what? From Celsius, from Celsius to Kelvin scale. What? To Kelvin scale. We use a formula like this one, that the temperature in Kelvin will be equal to the temperature in centigrade plus 273. And this is very easy. If you want to convert, what? If you want to convert temperature from centigrade to Kelvin, you will only add 273 with it. And this is very easy. Why? If you just see, look, how, let me prove it to you even. Look, what is the temperature in Kelvin and the temperature in centigrade? If you just see the division, what are the division between these two? It is divided into 100 division, as you see here, 100 division, and here also 100 division. So what is this ratio? The TK ratio and the TC ratio is 1. So TK is equal to TC. But you know, it starts from 0 or from 273? From 273. So add 273 to it. Okay, so this is the formula. Similarly, in the reverse, TC will be equal to TK minus 273. Right? Similarly, from Kelvin to Celsius, from Kelvin to Celsius, this, oh sorry, from, not, this is what I done in both the case. From let me do from Celsius to Kelvin, no, to from Celsius to Fahrenheit. Okay, so the temperature in Fahrenheit will be equal to 1.8 C plus 32. It is this, right? So how is it? So this is also very easy. For example, look, if I just prove this, I can even prove this to you. Here you see the temperature in Fahrenheit and the temperature in centigrade. So what were the division is? I told, see here 180 division and here 100 division. So what is this ratio? 180 and 100, right? So this will be temperature in Fahrenheit and temperature 1.8. So temperature in Fahrenheit 1.8 into temperature in some TC, like that. But you just see, look, it start from 0 or from 32, it start from 32. So look, you will add extra 32 with it. So this is how temperature from Fahrenheit is registered from centigrade. No, this is not a good way. TC better. So temperature in Fahrenheit is 1.8 TC into 32. This is how temperature in centigrade can be converted into Fahrenheit. Similarly, if you want from Fahrenheit to centigrade, so TF minus 32 divide by 1.8 and it will be your TC. But remember one thing, that while during your conversion, you never supposed to write degree with it. Okay, or for example, if you write here a degree centigrade and if you write here a 32, if for TC, for example, for TC, if you say convert 32 degrees centigrade into Fahrenheit, so yeah, 100, do it as 100 degrees centigrade. So there will be a big problem if you use or put the unit, for example, 1.8, and if you write here 100 degrees centigrade and plus 32. So this is confusion, right? A bigger problem. So never write the unit for this. Just write 1.8 because it is already in the Fahrenheit. 100 plus 32. And then write what? This will now become what? It will now become in the Fahrenheit the answer here and then write degree Fahrenheit. So this is our today lecture. Thank you very much for being here. So inshallah in the next lecture we will start about heat. Okay.